Welcome, Hornets, and thank you for joining me for part 2 of assignment number 5, where I'll be starting at number 23. So I've skipped a couple of problems which are following the same pattern that you should have noticed from part 1. Please go back and try them again if you haven't done so already. Now, in part 2, I've started at 23, and that's because I wanted you to notice what happens. See, notice this power right here is t to the minus 1, and it goes to t to the minus 2, okay? And I want you to think about it in that way. So if I let u equal 1 plus t to the minus 1, then my du ends up having a negative that comes out in front. Negative t to the minus 2 dt. Now, in this situation, I'm going to move the negative to the other side so that I have the negative dt. There we go, the negative t to the negative second. Now I can substitute it directly, putting the negative out in front. I then have my u to the third power, and I then have du. We can now do our 1/4 u to the fourth power plus c, and then we back substitute as we did before. And there's my answer. Once again, please feel free to double check by doing your differentiation. Let's go to number 25, please. Number 25 is using the radical, and I have 1 over square root 2x dx. So here I'm going to want to make sure that I think about this in terms of u equaling the 2x, the inside piece, so that 1/2 du equals the dx. I now have 1/2 the integration u to the negative 1/2 power du. I end up adding, and now notice I'm going to get 1/2, so 2 over 2 u to the 1/2 power plus c, and I simplify and back substitute. Once again, double check your answer by doing the integration. Number 27. 27 says solve the differential equation. So we're going to be working our way backward. This is where we're practicing those initial 3 steps, which the first step is to rewrite the problem. Second step is to separate our variables to both sides. So I'm going to have 4x dx plus 4x over the square root 16 minus x squared dx. And then we set up our integration. Now this piece on the left side is a very simple y equals. This is going to give me 1/2 x squared multiplied by the 4. And then I have this piece. Now in order to do this, this is where we have our u-substitution. See how we have an x squared and it goes to an x to the first. 16 minus x squared. Then I have du, and I'm going to end up with this negative 2. So I'm going to have negative 1/2 x dx. Now I can substitute it as negative 4 over 2 integration. Du is on top, square root of u on the bottom. And now I'm going to call it the negative 1/2 power. U to the negative 1/2 power du. And then I have my 2x squared y. Now as I integrate, add 1, multiply by the reciprocal, negative 4, u to the 1/2 power plus c, 2x squared equaling y, and I finish by the back substitution of what I originally called u. So negative 4 square root 16 minus x squared plus c. That's number 27. Okay, we're going to go to number 29 next. As we cruise through our problems, we are skipping the differential slope field, number 31 and 32. We'll be taking a look at those later. So we're looking at number 29. And I have my dy dx, and it equals x plus 1. And in the denominator, I have this x squared plus 2x minus 3 squared. And glad I have a bucket for my rain coming in. We're going to separate our variables again. Dy equals x plus 1, the quantity, x squared plus 2x minus 3, the quantity squared, dx. We're now going to integrate both sides. And now we need to look at this and say, well, my gosh, I got to get a u-substitution in here. How am I going to do that? Do I see an x squared anywhere and an x somewhere else? Or maybe it's an x cubed to an x squared, or an x to the fourth to an x cubed. Or maybe it's just x to no x. Let's look. I see an x squared piece and I see an x piece. I now know what to do. We let u equal the x squared plus 2x minus 3. And we take the derivative. Don't worry. Everything will work out. But it's got an extra 2. Oh no. If it's got an extra 2, we have to take that and divide it. So we're going to have 1/2 du equals. Now it's divided by the 2, and it's an x plus 1 dx. And we can now see it. Here it is here, and we're going to do our substitution. Dy equals 1/2, and we now have this du here, 1/2 du. Let's put our u, it's in the denominator, so a negative second power, and y will now equal 1/2. We now have plus 1, so we're going to have a negative times u to the minus 1 plus c. Y is equal to negative 1/2. We're now going to multiply 1 over x squared plus 2x minus 3 plus c. And I can now distribute that 2 in. Negative 1 over 2x squared plus 4x minus 6 plus c. And there's my answer. Number 33 is next. Now, don't let these next few problems give you any kind of an issue. We're doing the exact same thing. We're just now starting to get into our various rules that we've been practicing in class. For example, I take pi x equaling my u, and my du is just pi dx. Well, there's the pi and there's the dx. So it's the integration for the sine of u du, and we know that the integration of sine is going to be a negative cosine. So negative cosine of u plus c is my answer. And I have number 33. Now, all the rest are going to follow this basic pattern that we've just seen. So let's look at 35 real quickly. 35, the integration for the cosine of 8x dx. Let u equal 8x, du equals 8 dx. I don't have an 8 dx, so 1/8 du equals just the dx. 1/8 integration cosine of u du. We know that the integration of cosine goes to sine. 1/8 sine of 8x plus c is then my answer. 37. Once again, we just keep doing them over and over and over again. You don't let yourself get too hung up on any one little issue. There are so many that we could do. Notice here's that 1/2, that 1 over theta squared. That's that power going from a -1 to a -2. We have to look for it. We have to be aware of it. If we don't think while we're doing these, they're going to be wrong. So let u equal 1 over theta. If you wish, rewrite it as theta to the -1. Then you have du equals theta to the -2nd, and it's now a negative. And we have a negative du equals our theta to the -2nd d theta. Put it back. So we now have the integration, negative. This is the cosine of u du. And we're ready to begin. Negative sine of our 1 over theta plus c. And there's our answer. Continuing. 39. Alrighty. So if I have the integration for the sine of 2x cosine 2x dx, I've got something that's happening here. Once again, this is our number 39. And I'm looking at it saying, oh my, what am I going to do? But I have a sine to a cosine. I know that the derivative of sine is cosine. All right. So if I let u equal the sine of 2x, then du is got to be 2 cosine 2x dx. There's no 2. So 1/2 du equals the cosine of 2x dx. And I can now begin my substitution. I have u du. 1/2 u to the 2nd power plus c. Don't forget to multiply by the original 1/2. 1/4. I then have sine of 2x squared d plus c. Now, how you might probably see it is probably as the power in between, just like so. Alrighty. Now, as you continue through these, they're all going to follow that same basic pattern that you're seeing right now. All right? Don't let things give you too much of a problem, and I think you should be fine. Alrighty, I'm going to go ahead and stop this. We're going to start part 3 in a moment, and I will probably begin down toward the next page as we take a look at numbers 55 all the way through down toward 79. Thank you very much. I hope this is helping. Remember, please click like if you are finding this useful. Be well and take care. Thank you. And part 3 will be next.